day, everyone. I want to welcome you back to class. Today we are looking at interpretation and reporting descriptive analysis. We bet how to run our analysis, descriptive analysis, t-test analysis, correlation analysis, regression analysis, either linear regression or multiple regression. We've done that. Now, after you've done that, you cannot just leave your answer like that. You have to interpret your results. Now, from the output view, I have to copy this. I have copied this one for age. Now look at this place, age. Now I have my frequency and the total number is 60. I have 29 within 9 to 10 years. 11 to 12 years, I have 20. 13 to 14 years, I have 11. And this place is the percentage. It's the percentage required for that work. And that is what I have done. Now, this is a percentage that we need to report. This is a valid percentage. Means talking about probably if there is a one that is missing, what we are going to have here is going to be totally different from what we are going to have here. Is that taken now? Now, if this percentage you are going to report, now look at this table, the one I put here. I said from age distribution table, from this age distribution table, 8.3% of the respondents are between 9 to 10 years, this place, and 33.4% are between 11 to 12 years, and 18.3% of age are between 13 to 14 years from this place. And by the time we add everything together, you will get 100%. Okay, now this is your report. Now from this place you can now have your conclusion from this place. We are looking at this percentage. It's telling us that the majority of students or respondents I have in this class during this questionnaire or mark test is the student between 9 and 10 years, because the percentage is more than the between 11 and 12 and 13 and 14. Therefore, I cannot conclude and say, now from the table above it shows that majority of students are from 9 to 10 years. Is that taken now? And for a layman too, I can decide to use a graph to show my results. Now, and I use this histogram, this bar chart. Rather, I use the bar chart to show the analysis of age. This is for between 9 to 10. Look at the height. Between 11 to 12, this is the height, and 13 to 14 years, this is the height. We are looking at this. It's telling us that the majority of the student now is from 9 to 10 years. Can you see now? 9 to 10 years, and we are free to do that now. We are free to do that. Is that taking? You can see it. Anybody can see this one and easily analyze that majority of your respondent is from 9 to 10 years. Okay, let's move for that. Now, the class. I have 3 classes, GS1, GS2, and GS3. Now, these are the frequencies. For GS1, I have 19. For GS2, I have 33. For GS3, I have 8. Now, these are the percentage. For GS1, I have 31.7. GS2, I have 55.0. And GS3, I have 13.3. Now, we can now report this and say from the table here, from this dialog box I put here, say from the distribution table above, 31.7% of the respondents are in GS1, 50.0% are in GS2, and the remaining 30.3% are in GS3. Yes, these are the one I painted yellow. And now, from this analysis, we can easily tell them, because the major thing of this is to describe. Therefore, from the above table, it shows that the majority of students are in GS2. Why? Because the percentage. Even when you have the percentage of GS1 and percentage of GS3 together, see, percentage of this one and this one together, they are not up to the percentage of the GS2. And from there too, I can show you to layman. See, these are it now. This is GS1, GS2, GS3. Look at the picture for the charts. You see now, and it's taller than the 2. Therefore, the GS2 are more in that study, are more than any other class in that study. Okay, the next one is the gender. And here I have male and female. These are frequencies, these are percentage, and the valid one and cumulative. Okay, I have not talked about cumulative. Cumulative is adding up. I will tell you how you can get. Even that one is right there on your output, but you don't need that one during the your explanation. Okay, now 24% here, and calculating it is telling me that I have 40% of the male, and 36 of frequency. I have 60% of the female. Me are looking at this. I cannot just come now from gender above. It shows that from the gender table above, it shows that 40% of the respondents are male, while the remaining 60% are female. And from this, what we have, it shows that there are more females in that school, and our table also is telling us something to indicate for layman that cannot interpret mathematical language. A layman can see this your graph, this your bar charts, and say okay, this your bar chart, and say okay, yes, this one is taller than this, so that the people that are here are more than this. That is about the gender. Is that taken? All right. Okay, let's move further. Okay, the next one is I have mathematics achievement test. Look at it, mathematics achievement test. I have the frequencies here, 1, the 9, 9, 7, up to 2, and these are the score that they score during the marking from 2 to 20. These are their score from 2 to 20. All right. And those ones that score 2, telling you is 1. Those ones that score 12, 9. Those ones that score 13, 9. Those ones that score 14, 7. All along to those ones that score 20, they are 2. And their percentage are given to us here on this column, which I painted with yellow here. These are the value. You check that this value and this percentage, the value percentage and the ordinary percentage, they are equal. Why? Because there is no one that is missing. Therefore, the cumulative percentage is telling us addition of this. No, this is 1.7. The 1.7 will be here. Now 1.7 to 1.7 plus 15.0, that will give us 16.7. 16.7 plus 15.0, that will give us 31.7. 31.7 plus 11.7, that will give us 43.7. 43.7 plus 13.7, that will give us 56.7. All along until you get to 100. But it must also equals to 100%. Now, we are looking at this. You can get whatever you want to get here based on this percentage. Is that clear? Now, when I checked through, I discovered that the highest percentage I have is 15, while the lowest is 1.7. And from here I can conclude and say from the mathematics, because the mathematics achievement test, so the majority of respondents score 12 and 13. Why? Look at 12. The 12th line, you see now, is 9 and 15. Look at 13, you see now, 15%, and there's no one that is up to that. That's the majority of them score 12 or 13. That's what we have here. You can also as well interpret other one. Okay, I can also say, okay, the least percentage is 1. The person that score 1, which is 1.7% out of the total percentage. Is that taken? All right. Okay, let's continue. That's for mathematics achievement test. Now the next one is English. That one too, we have a table for it. You see now, mathematics achievement table. Look at the table. You see the 13 and 12 and 13. Look at the height. They are the one that they are the tallest among them. You see, we have this for 16, we have this for 18. Look at the one for 2. You see now. Therefore, from this place, somebody, the layman, can interpret that, okay, with what I have here, or with what you are giving me, it is this 12 and 13, they are equal and they are taller. Therefore, they have more than any other bars that you have here. That's mathematics. Now, let's move down to English achievement test. English achievement test. This one, English achievement test, we have this. The same thing too. Now, the least number score valid is 12. The highest number score is 19. How many students score 12? 7. 13? 8. How many score 14? 10. How many score 16? 9. How many score 17? 7. How many score 18? 9. How many score 19? 4. And we have all this. And once you are through with that, then what is the next thing? The percentage. The valid one is still the same because there's nothing missing. They are all 60 and they have it completely. Okay, and this is the valid percentage and cumulative, as I've explained. That one will be in your table. We don't need to use it for explanation. What we need is frequency and percentage. Now, for those people that score 12, their percentage is 11.7. Those people that score 10, their percentage is 16.7. And from what we have here, the higher frequency here is 10, and it also has the highest percentage, which is 16.7. There's no another one that has that kind of percentage. Is that taken? There's no one. Therefore, from this place now, we can say from the English achievement test E distribution table, majority of the respondents score 14 with 16.7%. That's it. And you also get the least. That the least is 7 with the 47 with a percentage of 11.7%. That's your. Now you can therefore conclude that from this place, majority of students score 16.7. Majority of students score 14. Is that taken? All right. Now that is for English achievement test. Now, the graph also is well explanatory. That's the graph, the bar graph. You see now, the one that is 40 is the tallest. You see, this is the bar English achievement test graph. And this is not the only graph. You can use pie charts. You can use bar graph. You can use line graph. I decided to use bar charts. You can use pie charts. You can use line graph. You can use histogram. There are many at that place. You can use it. Is that taken? All right. Let's move down. So that is descriptive. Under that descriptive, we'll talk about crosstab. The crosstab. And that crosstab just simply a chi-square test. Now, the crosstab, that is, I officially the crosstab check the what I've taught you under the test analysis. I dealt with crosstab statistics. I now copy it down here to explain. Our valid is 16 number, not missing. Missing is 0. Therefore, that's why you have 0% here, and our total is 0. Yes. Okay. Now just telling us the summary of everything. These are crosstab. What have I done as crosstab means one is moving together with two. I have English achievement test and mathematics achievement test that I want to put together. Now, the Pearson chi-square that I have is talking about this one, because under that crosstab you will get chi-square, Pearson chi-square. Now look at Pearson chi-square here. I have a 61.731 with DL. What's the meaning of the degree of freedom? Then associate an associative value of significance is telling me that I have 0.522. And with this value that I have here, this 0.522, no, it's telling me that it is not significant. They are not related. They are not related because why? If it is significant, it should be less than 0.05. And here I have 0.522. It's telling me it's not significant. And likely ratio, this is what I have. And the degree of freedom I have 63. If you share this 63, we discover that they are telling me that they are not they are not related in one way because of this value I have here. And now let's see. Instead the 80 cells 100% have been expected can less than 5. The minimum expected count is 0.7. 0.7. Look at it. The minimum expected is 0.7. All right. The next one is ratio statistics. And ratio, what mean of ratio? Like fraction. Okay. This is ratio that I did. And what did the one I put in is age and class. Age and class. And from my age and class, this is the ratio statistics for that one, and this is processing. For age and class, this is a coefficient of relation between the two variables, the variable of age and the variable of class. Now, the coefficient of relation I have is 62.1%, which is very good. And the result is very good. Why? Because what I have as 62.1 is very good. All right, that is about the ratio statistics. And in this way we are going to stop for now, and next time we'll continue with t-test analysis.